Hello, check. Hello, check. Hello. Hello, check. Hello, check. Hello. Hello, check. Hello, check.
Hello. A very good morning to each and every one of you gathered over here and those attending over online. It's our pleasure to welcome all of you to this first international conference on advances in naval architecture and ocean engineering, iCANOE 2021, on the occasion of the Golden Jubilee celebrations of our university. It's now time for us to formally commence the inaugural session, and we would like to get started with the invocation. So may I now request Mr. Ashwin DP, third semester BTech student, to lead us in the invocation.
ഹൃദയരാഗതന്ത്രിമീട്ടി സ്നേഹഗീതമേകിയും കർമ്മഭൂമി തളിരിടുന്ന വർണ്ണമേകിയും നമ്മിൽ വാഴുമാദിനാമം ഇന്നു വാഴ്ത്തിടാം. ഞങ്ങൾ പാടുമീ സ്വരങ്ങൾ കീർത്തനങ്ങളാകണേ, ചൂടുവയ്ക്കുമീ പദങ്ങൾ നൃത്തലോലമാകണേ. കുഞ്ഞു വീടിനുൾക്കളങ്ങൾ സ്വർഗമാകണേ. അമ്മ നൽകുമുമ്മ പോലും അമൃതമാകണേ. പൂർണ്ണമീ ചരാചരങ്ങൾ ഗുരുവരങ്ങളാകണേ. ഹൃദയരാഗതന്ത്രിമീട്ടി.
To welcome is to show honor. May I now request Dr. K. Shivaprasad, Professor, Department of Ship Technology, to deliver the welcome address.
Good morning to all. As we all know, Cochin University of Science and Technology is celebrating its Golden Jubilee. And as part of our Golden Jubilee celebration, Department of Ship Technology is organizing a two-day international conference on advances in naval and offshore engineering, iCANOE 21. Our Department of Ship Technology, has been the flagship course of this university since its inception in 1975. However, due to some unknown reason, department could not flourish in research and development. I hope this Golden Jubilee celebration and this year will mark the beginning of our advance also. Department of Ship Technologies advance in engineering, research, and industrial development. So let this be an occasion, an auspicious occasion for that beginning also. Let me go straight into my official duty of welcoming distinguished guests and the participants and audience. President of this function is none other than our beloved head of the department, an academic, Dr. Madhuragan, an academic enthusiast and an institution builder. He has been working with teachers and students and other industrial personalities to uplift the condition of this department. On behalf of iCANOE 21, I take this opportunity to extend my hearty welcome to Dr. Madhuragan sir. Next is Honorable Vice Chancellor, Dr. Professor P.N. Madhusudanan. He has been with us. He was a professor here. He was a researcher here in this university. And presently he is holding the post of Vice Chancellorship. He has been with us. And one point in this context that I would like to extend, that he is always for industry institute collaboration. And he has been helping us to have industrial experts coming over here and training our students to excel in the other areas other than academics. So I take this opportunity to On behalf of iCANOE 21, I take this opportunity to extend my heartfelt welcome to Dr. Professor Madhusudanan, Honorable Vice Chancellor. And I also would like to mention that this conference was, made possible with his great help, because we were having only 5 faculty members, and due to his pressure and initiation, we could get another 6 faculty members, and that made this possible, I think. Kochi was considered from time immemorial as a queen of Arabian Sea. Because of some other reasons, the status of Kochi as queen of Arabian Sea was slightly dimmed down. But with the help of Madhu S. Nair, who is currently the chairman and managing director of Cochin Shipyard, due to his effort, Kochi is again taking back its glory. It's becoming again the queen of Arabian Sea. And he is an alumnus of this department. He started his career in Cochin Shipyard and reached up to the post of chairman and managing director. He's one among the alumni of Department of Ship Technology and a well-wisher. I take this opportunity to welcome Sri Madhu S. Nair, chairman and managing director of Cochin Shipyard Limited. Dr. Abdul Rahim needs no introduction to the students and scholars of department, teachers of Department of Ship Technology. I think more than an alumni, he's one of the builders of the institution builder of Department of Ship Technology. His contribution to develop this department has been immense. And he is the first non-Japanese director of a Japanese giant, maritime giant, called Class NK. So that is the reputation of Dr. Rahim. And he always, I think every year he used to visit at least twice to see what's happening here, to support our efforts. So I take this opportunity to welcome Dr. Rahim. Next in the dais is none other than General Manager of Class NK, world's largest maritime industrial establishment. He's looking after the operations in India, Class NK's operation in India, and he has been associated with this department, especially in implementing the MOU between Class NK and Cochin University. And he's now coordinating the Best Project Award, Class NK Best Project Award. He's here to also give away the award. I take this opportunity to express my sincere welcome to Sri Sumitran Sambats. We have clubbed 2 functions together in this inaugural function. One is the inaugural function of iCANOE 21, and the other one is the distribution of Class NK Best Project Award 2021. And we have with us the first Best Project Award winner, Shahid, and the second Best Project Award winner, Richard Johnson. He's absent. He's working somewhere in Gulf in Daman Shipyard. So his mother is here. Welcome. And also we have Nikhil Shukla, the third Best Project Award winner. I wholeheartedly welcome the awardees and their parents. I also would like to welcome the knowledgeable keynote address, the invited speakers, the paper authors, chair and co-chair of this iCANOE 21. I wholeheartedly welcome the participants of the conference and those participants, those who are joining in the online mode also. I take this opportunity to welcome them also. And this is made possible with the help of sponsors. That list of sponsors are displayed. So I also take this opportunity to welcome the sponsors of this function. And not the least, I am also extending my heartfelt welcome to Dr. P.K. Sadish Babu, convener, and his team. Thank you.
Thank you, Professor Shiv Prasad, for that welcome address. Next, may I request Dr. Madi Alagan, Professor and Head of the Department of Ship Technology, to deliver the presidential address.
Good morning, all. Honorable Vice Chancellor, Professor Dr. K. N. Madhusudanan, the chief guest of the function, Sri Madhu S. Nair, Dr. Abdul Rahim, Corporate Officer, Regional Manager, East and South Asia, Class K, Mr. Sumitran Sambat, General Manager, Class K, Mumbai Office, Dr. Professor K. Prasad, Dr. Sadish Babu, teachers, students, research scholars, parents of the Class K awardees, naval officers, Commander Deepak Sebastian, and all others who have joined for this international conference, not changing stops. I'm deeply indebted to Dr. K. N. Madhusudanan sir for having come over here for gracing this occasion. I'm also very much grateful to Sri Madhu S. Nair, CMD, Cochin Shipyard Limited, Dr. Abdul Rahim, corporate officers of Class K, and Mr. Sumitran Sambat. Man is the goal-striving being. Without goal, we cannot achieve the success. So the department has a goal to continuously evolve into globally recognized department. And without the goal, no one can achieve success. So with this goal, the department has produced many naval architects, students who are in flying colors. Last year, we had a placement record of 90%. And this trend will continue to happen in the years to come, because once the COVID is over, we'll be having more placements. In that cases, more industry will come forward to take our students. Some of the faculty members have also produced well-renowned journal papers. And also, some of the faculty members have completed their projects, like CAS projects from NPOL, and also the other consultancy projects. So in this regard, this department has unique identity, which is the naval architecture as a core field. But it is not sufficient. We have to go out of this box, think differently, interact with the other departments so as to have a goal achieved. Creative thinking is very, very important. The industrial, industry 4.0 is the new trend which is coming up nowadays. It is originally coined by German government. Now it is adopted almost all industries, including shipbuilding industries. I take this opportunity to thank the university for supporting this event, and also all other sponsors, alumni members. And I wish the conference grand success, and looking forward to have a positive outcome. Thank you very much.
Thank you, sir. May I now call upon our Honorable Vice Chancellor, Professor Dr. K.N. Madhusudanan, to deliver the inaugural address.
President of the function, Professor Madhiyazhan, Sri Madhu S. Nair, Chairman, Managing Director, Cochin Shipyard, Dr. Abdul Rahim, Corporate Officer, General Manager, Middle East and South Asia, Class NK, Mr. Sumitran Sambat, my esteemed faculty colleagues, distinguished speakers at the conference, participants, research scholars, students, ladies and gentlemen. It's an honor to be part of the International Conference on Advances in Naval and Ocean Engineering. As we know, Department of Ship Technology is one of the prestigious departments of the university. We are not at just producing graduates, as we all know. We are at creating leaders. Telling examples are in front of you, such as Sri Madhu S. Nair, Dr. Rahim, and hundreds of many others. So we have emerged as global leaders in this area. And as far as university is concerned, this department and its graduates always helped us in projecting ourselves in an international scenario. This particular conference, I'm sure, will be handling the most advanced topics in naval architecture and shipbuilding, various aspects of this more or less hybrid technology. As in many other areas, this area is also undergoing big changes. Professor Madhiyazhan has mentioned about Industry 4 and other developments. We know that naval architecture and shipbuilding also is undergoing changes on these lines in terms of automation and new design tools and concepts. And another important area of course, which is again emerging, is in the present context, climate resilient design and building. So we have to incorporate all this futuristic outlook in our curriculum also, so that our graduates will always be ahead of others. We have very eminent speakers at this conference who are dealing with all the major aspects of naval architecture, like structure, stability, hydrodynamics, and so on. I'm sure this will be a platform for exchanging ideas and coming up with new ideas, new collaborations for taking the research in this field forward. Our faculty and research scholars, as well as students, will get a very good exposure out of the deliberations at this conference. I'm sure this will be a wonderful experience which will help us advance our own activities. I wish all the conference all the very best and declare this conference inaugurated. Thank you.
Thank you, sir. Thank you for officially inaugurating this event. Next, we have the address by our chief guest, Mr. Madhu S. Nair, Chairman and Managing Director, Cochin Shipyard Limited. Over to you, sir.
President of the function, Professor Dr. Madhu Ezhugan, Honorable Vice Chancellor of Cochin University of Science and Technology, Professor Dr. K.N. Madhusudanan, Dr. Abdul Rahim, Shri Sumitran Sampath, Professor Shiv Prasad, Convener of the iCANOE 21, Dr. Satish Babu, respected faculty members, dear friends. First of all, let me start with complimenting all of you for convening, conceptualizing, and actually today and tomorrow coming in here together to have this international conference on advances in naval and ocean engineering, iCANOE 21. As was mentioned, Cochin University of Science and Technology is celebrating 50 years, and the Department of Ship Technology, one of the foremost departments in the university, also sailing along. These kind of discussions, these kind of platforms and forums are only natural. And these days, going through a pandemic, today we are getting here for a what we call the hybrid mode of discussions. There are physical events plus online events happening simultaneously. I think that's the order of the day as we move forward. But the most important part is discussions should happen. Because if discussions don't happen, we get stale, we lose energy. And what is the best method to have discussions? Get together the right people and have thematic discussions. And this is what I think an academic institution should really prop up. And the academic institution, when it connects with the industry, when it connects with academia worldwide, then you get the best in theme discussions happening. We are all aware that today the world is going through a real technological onslaught. Every facet of our life is being impacted by technology. And as engineers, forget which field you're operating. Today, in ship technology or naval architecture, we would be more connected with the ships or the maritime domain, but that really doesn't matter. At the end of the day, it's how technology is impacting. So if you decide to look only at the maritime space and only at the maritime technologies, then I think we are actually missing out the larger picture. Because the larger picture is unfurling in this, what I call is a technological onslaught. And this technological onslaught is all pervading. It is all pervading because it stems from certain aspects, which in a larger aspect, people would call coming from sustainability. That's a word which can be all pervading. Now, how does sustainability come and impact you? Sustainability would lead to various other themes, and those themes are actually impacting this particular space which we all thrive and we all work. So coming back to the maritime space, there are at least a few large themes and few large spaces emerging. And if I try to take the three of the largest themes that's happening around us, one would be digitalization, the other one would be decarbonization, and the third would be various forms of autonomy. So digitalization, decarbonization, and autonomy. And these are these separate themes? These are not separate themes. They are all interlinked. Are these only specific to the maritime domain? Definitely not. So if the recently concluded COP26 at Glasgow was discussing how to move forward for a sustainable world, and if I always request people whom I interact with, please go and watch this movie by David Attenborough, which is today there on Netflix, The World We Live In. It's David Attenborough is one of the world's foremost sustainability advocates, let's put it that way, because today when he is celebrating 94 years plus, probably that's the way. When he probably started his life, the world wouldn't have talked, but today when he is 94 plus, probably I think we should call him a sustainability advocate. The entire world is talking sustainability, and from that stems a lot of other things. Now, are these topics, are these themes generally in front of us? How do we get these themes into discussion? How do the students and the faculty of this particular department, how do we connect with the best-in-class discussions on these themes? I think conferences like this play a very, very important role in it. Come back to our own place. Come back to India. This world, we cannot stay away from anything. That is why when we are talking about COP26, and if you have closely followed COP26, the last declaration, when it came, there has been a fierce, let's say, a little bit of a fight between the so-called developed countries and the developing or the underdeveloped countries. And the last declaration has actually led to a lot of heartburns. And if you have not really seen that sentence, please go back and read what the COP26 declaration says. It talks about, there was this sentence to be used as coal will be phased out, but the final declaration said coal will be phased down. So the questions which the developing countries, including India, was strongly asking is, why only pick up coal? There are other fossil fuels also. Gas is also a problem. So why are we talking only about coal being phased out? So at the insistence of countries like India, which has not gone very well with many of the other countries, the final declaration says coal will be phased down. Why I am mentioning this is this important for us? Is this important for this seminar here? Is this important for this conference? This is where the entire thing is flowing. Today, in our normal lives, we all would live out of a mobile phone. And if you pick up a mobile phone, if I have a phone and you have a phone, does it behave similarly? It doesn't. It doesn't, because there's a lot of AI that's playing in it. It's actually taking inputs from you. It's playing into your own mobile, and it's giving you a lot of inputs. Are we really appreciating this impact it's doing to us? When we check up, when is the last time we probably walked into a bank, and tomorrow when somebody is talking about cryptocurrency, when somebody is talking about blockchain, and somebody says blockchain can be adopted for trade, blockchain can be adopted for issuance of certificates. Do we really realize what is this technology and what is impacting us? Or do we think that, no, I am in the area of ship technology, so probably this doesn't impact me? The world has changed. 50 years of Cochin University, 50 years of the Department of Ship Technology. Interdisciplinary engineering is a key. And unless we understand, and unless we appreciate, and unless we create the energy within ourselves to learn that new, exciting knowledge that is unfolding in front of us, we will be left far out. I have passed out of this university in 1988, so it's long way back. But the fact is, what probably has happened in the last 30 or 35 years, take my word for it, much more will happen in the next 3 years. This is a rapid pace at which technology is changing. So unless we get these kind of discussions, and not once a year, we need to have these discussions much more. We need to be participating in such discussions elsewhere much more, because the rapidity with which this change is happening. Today, like Abdul Rahim lives out of London, and UK has gone on record and said 2030 onwards, there will be no IC engine cars in London. The famed double-decker buses in the city of London, a part of those are running on hydrogen. Are we clear what's happening? We have heard about hydrogen. Are we clear that today, one day, probably IC engines may go off, and today we would all, in our marine engineering, would all be learning about 2-stroke, 4-stroke engines, maybe a little bit into gas engines. But do we talk about fuel cells? Do we talk about how EV is unveiling in front of us? A lot of exciting things. I wish I could be reborn again in this particular era, and this rapid change, so that this exciting times are there in front of us. I actually really feel great for the people in front of me, the youngsters in front of me, the researchers in front of me, that you're actually in a very exciting era. Technology onslaught, the way, and technology onslaught, not just sitting in some labs or sitting in some supercomputing centers somewhere in the world, inside your mobile, on your fingertips. And this is where we are. I think this discussion, we can't just go back and talk about classical theory, as Professor Madhusudan rightly brought it out. Classical theory is always the backbone. We can never undermine that. Those theories, the theories of physics, chemistry, and mathematics, and the basic theories which we learn in our topics, these are always going to be the backbone. So everyone must be absolutely clear and sound on those, because only from there, then you get into the interdisciplinary mode. And unless you actually take from those interdisciplinary mode and try to understand what is happening in front of us, I think extremely exciting times happening. Again, going back, decarbonization will throw out a lot of possibilities, a lot of large thematic aspects. Most importantly would be what the world is today calling the hydrogen economy, and which way hydrogen will come, what is green hydrogen, how will hydrogen come in, and what forms of hydrogen will be applicable in our space. Coming to digitalization, each and every facet what we are talking, ships are going to be connected, shipyards, manufacturing institutions are going to be connected, and how you talk all these concepts about digital twin and how we will actually extract from it will come into the forefront. Talk about autonomy, vessels will be autonomous. What levels of autonomy? Should we go up to level 5 or should we be at level 1? That's basically depending on what is the role that's intended to play. I am very happy to inform you that if you are not already aware, Cochin Shipyard here in Kochi is building 2 fully autonomous vessels for a Norwegian client. Currently, the vessel has been launched, and early next year, we'll be delivering those vessels. So these are things that's happening very near us. I should admit that the technology for those autonomy vessels are not ours. It's coming elsewhere. But we are also very, very keen, and we are putting in the pieces together to develop indigenous autonomous technologies, partnering with various others. We will one day develop our own indigenous autonomous technologies. If we're talking about hydrogen, we will develop our own fuel cell vessels in whatever small form it is. But cooperation in all these aspects is called for. I wish the university would also strongly support whatever is needed. Just coming, before coming here, we were having a small chat in the HOD's room. I, on behalf of Cochin Shipyard and on my personal behalf, can assure you that whatever Cochin Shipyard can do for this department, whatever is possible, it will be done. That's for sure. That can be done. But what I seek from the university and what I seek from the department is energy. Absolute energy. Without energy, nothing flows. And if the energy is there on this side, I can assure you, we will back it up. And it's not a one-way traffic. It is not that Cochin Shipyard sits at a different level and then it's flowing from one side. I am also extremely keen. I talk to my colleagues in Cochin Shipyard that please do this partnership because it's a two-way traffic. For me, for a shipyard, for an industry, getting connected with the academic institution is great. It is great. We are trying to do that with various others. For the academia, connecting with the industry, in whatever form it is actually great. Let us build up this two-way traffic. Let us build up more discussion forums like this. And I wish this conference the very best. I wish it invigorates the mind, creates much more energy, and let the energy flow. Everything else will follow from that. Thank you, and all the best to this function. Jai Hind.
Thank you, sir. Thank you very much for that enlightening speech and inspiring us to look forward and look higher. Thank you. Next we have, may I call upon Mr. Sumitran Sampath, General Manager, Class NK Mumbai office, to deliver the felicitation speech.
Dr. K.N. Madhusudanan, Honorable Vice Chancellor, Cochin University. Dr. Mati Aragan, Head of Department of the Department of Ship Technology. Yeah. Mr. Madhu Nair, Chairman and Managing Director, Cochin Shipyard. Dr. K. Sivaprasad, Professor of Department of Ship Technology. Dr. Abdul Rahim, Corporate Officer and Regional Manager of Class NK. Participants, students, parents, ladies and gentlemen, wish you all a very good morning. It is indeed an honor for me to make this address among very young minds in this opening session of this international conference on advances in naval and ocean engineering. Such conferences are already enumerated by the distinguished speakers earlier, provide a platform for exchange of ideas between academia and the industry. Also, it provides a platform for all of us to update our knowledge, what is new in the field, which is very important as we do never stop learning throughout our life. And also it forges possible ties between academia and the industry. One such example we can see is the long relationship we have had between Class NK and CUSAT over the years. Class NK instituted awards as the best student projects in CUSAT somewhere from 2006 onwards, and it's been continuing ever since. CUSAT also has carried out some research projects for Class NK over the years, and so it has been a very beneficial relationship for both of us. Research plays a very important role for Class NK because we develop our rules based on research. And Class NK also participates in many research projects jointly with the industry players. Notable projects today are mostly aimed at GHG reduction with an aim of attaining zero emission. And such projects, many of the projects have become very successful in Japan. To state one is the construction of a liquefied hydrogen carrier that's to ply between Australia and Japan. Which has recently completed its trials and expected to put into service soon. Another interesting project is related again to autonomy. As Mr. Madhu Nair very correctly said, identify 3 focus areas today. And we are preparing some guidelines for autonomous ships, because autonomous ships, unlike manned ships, or even depending on the grade of level of autonomy, don't have real guidelines which are suitable for them. As you know, one of the biggest conventions, international conventions, which is SOLAS, which means safety of life at sea. Now, if there's going to be fully autonomous ships, which doesn't have life on the ship, then would that same convention be applicable? No, it would not be. We have to fine tune the convention to also apply to implementation of artificial intelligence, maybe defects which may come up, may be vastly different from human error. So that work is ongoing as of now, and we will be making a presentation on that, a paper presentation on this tomorrow in this very conference. Now, as the next agenda, next item on the agenda is the presentation of the NK Awards for the best projects. I would not like to keep you waiting for those, and I'd like to conclude my brief speech. And I wish the conference all the best, and also I would like to congratulate the award winners of the Class NK Awards. Thank you.
Next, we have the distribution of Class NK Awards for the best student projects. As Professor Shiva Prasad has already mentioned in the beginning, we used to organize this as an event every year. And this time we had the privilege of conducting it or organizing it along with this conference. And we have with us here Dr. Abdul Rahim, Corporate Officer and Regional Manager, Middle East and South Asia, Class NK, to distribute the award. May I request you, sir, to come forward for the distribution of Best Project Award. Well, every year we select the 3 best projects that are done by our BTech students. And this year also, we have done the same. And the 3rd best project of this year goes to Sub-Lieutenant Nikhil Shukla, and for this project on the design of 130,000 ton CMB LNG carrier under the guideship of Mr. Mohammed Ashik. May I request you to please receive the award. The award for the 2nd best project goes to Mr. Richard Johnson for the design of an 80,000 ton FPSO and under the guideship of Professor K. Shiva Prasad. In the absence of Mr. Richard Johnson, may I invite or may I request his parent to receive the award. And the first prize or the best project award goes to Mr. Mohammed Sahid for the design of a 600 CU dual fuel LNG pure car and truck carrier. And that was done under the guidance of Professor Keshwa Prasad. May I request you to please receive the award. Congratulations to all the winners. So now may I request Dr. Abdul Rahim to share a few words.
Good morning, ladies and gentlemen. I don't wish to take much of your time. First of all, let me congratulate all the winners. That doesn't mean that others haven't put in effort. They also put in all their effort in doing their project, but we only have 3 awards, so that was given to 3 of the students, the students. And as I told you, iCANOE has instituted this award since 2006, and it is going strong. And as my colleague, Mr. Sumitran Sambat has mentioned, iCANOE is bringing out quite a number of guidelines on autonomous ships, on hydrogen transportation and all. So I hope in the future, the students will take up these niche areas for their project so that you will get to learn a lot more about this. So that's all I want to tell you, and congratulate all of you once again. Thank you very much.
Next is the release of conference proceedings. We have received a number of abstracts and papers in response to the call for papers for this conference. Around 30 full articles have been accepted and compiled into a conference proceedings. So now it's time to release those conference proceedings. So may I kindly request our Honorable Vice Chancellor, Professor Dr. K.N. Madhusudanan, to kindly release these conference proceedings by presenting it to our chief guest, Mr. Madhu S. Nair. Thank you, sir, for releasing that conference proceeding. As a token of our appreciation for gracing this occasion by being present here, we would like to distribute, as a token of appreciation, mementos to our dignitaries. May I invite Professor Madhyaragan, head of the department, to distribute the memento to our guest. So first, we would like to give the memento to our Honorable Vice Chancellor, Professor K.N. Madhusudanan. for gracing this occasion with his presence. Next, may I request our chief guest, Mr. Madhu S. Nair, Chairman and Managing Director, Cochin Shipyard, to receive the memento. May I now request Dr. Abdul Rahim, Corporate Officer and Regional Manager, Middle East and Southeast Asia, Class NK, to receive the memento. May I invite Mr. Sumitran Sampath, General Manager and Class NK, Mumbai office, to receive the memento from our HOD. Thank you, sir. Thank you for gracing this event with your presence. Thank you. Now, I call upon Dr. Satish Babu, Associate Professor and Convener of iCANOE 2021, to propose the vote of thanks.
Very good morning to one and all. Respected Vice Chancellor CUSAT, Chairman and Managing Director, Cochin Shipyard, Dr. Abdul Rahim from Class NK, and Mr. Sumitran Sampath from Class NK, our respected Head of the Department, Dr. Shiva Prasad, professors, invited speakers, alumni members, authors, reviewers, staff members, Commander Deepak Sebastian, my friend Shaji PJ, dear students, sponsors, ladies and gentlemen. Well begun is half done. So we are very happy that our international conference, iCANOE, is finally on, and we are going to have 2 hectic days of 2 keynote address and also 32 paper presentations, FIR online and FIR offline. It is in fact truly international. The inaugural session is being watched across different countries. And I'm very happy that in a very short span of time, we could bring up our auditorium to a place where we can stream an international conference. Our team started working maybe in end July or early August, and the response that we received from all stakeholders in the industry has been tremendous. And our team was always running behind schedule, and we always found solution to get back to our schedule. And so today the conference is on. As our head of the department has brought out, Honorable Vice Chancellor has been extending his full support to all initiatives taken by our department. Thank you very much, sir, for your encouraging words and also coming and inaugurating this conference. Thank you, sir. Mr. Madhu S. Nair, CMD, Cochin Shipyard, always finds time to be here in the department in spite of his busy schedule whenever we are having any major event. So, sir, we are all looking forward to commissioning of our indigenous aircraft carrier by Cochin Shipyard. You always give us confidence to think big whenever we are looking for organizing something. And thank you once again for coming as chief guest in today's functions. Thank you, sir. Well, the department is very lucky to have constant support of Class NK. And today we have Dr. Abdul Rahim and Mr. Sumitran Sambat, who flew down to Cochin for coming and participate in this function, and also to distribute the best BTech projects to the students. I was part of the jury for selecting the students, and I found these students have done a wonderful job in your project. So thank you, Dr. Abdul Rahim and Mr. Sumitran Sambat, for being part of this function. Thanks. Dr. Madhyaragan, head of the department, is also the chairman of organizing committee, and this function is organized as per his guidance and his directives. So thank you, sir, for the constant support while organizing this event. Thank you very much. Dr. Shivaprasad is actually the creator of the acronym iCANOE. So we had a brainstorming session how to go about it, and he came up with this suggestion, and we were quick to capture this. So thank you, sir, for this this word iCANOE, especially a welcome address, and also for the constant intervention whenever we were looking for some guidance. Let me also thank Commander Deepak Sebastian, Officer in Charge, Naval Construction Wing, and Mr. Shaji PJ, the General Manager, Cochin Water Metro, for coming for this function. Thank you. Let me also thank Dr. Manoj Isaac for conducting this function very well. Special thanks to Dr. Krishan Gutti and Dr. Suresh Rajendran from IIT Madras, Mr. Jadesh Chandra from Cochin Shipyard, Dr. Reggie John, Scientist G, and Ronnie Francis, Scientist F from NPOL, Mr. Anil Das T from Conceptia Technologies, Bangalore, Dr. Subbarao from NIT Karnataka, Dr. S.K. Jalan from VSSC Trivandrum, and Dr. Praveen from NSTL for agreeing to be part of this conference as keynote speakers and session chairs. Thank you all. Next, I would like to thank all our reviewers who have made valuable suggestions while reviewing the abstract and also full papers, most of the time at a very short notice. Thank you very much. My sincere thanks to the Department of Ship Technology, Alumni Association, Alumni Society, Dostas President, Executive Committee, and all alumni members for their wholehearted cooperation to this department. Here, I would like to specifically mention the support of 16th batch alumni of Department of Ship Technology, who have supported in big way for creating this video conferencing facility as a gift to the department on their silver jubilee year. Thank you very much. The credit of organizing this conference goes to the Ship Technology team, which comprises of all professors, all official staff, research scholars, and our students, NAS. All have made substantial contributions, and my sincere thanks to each and every one of you in the organizing committee for stitching this event and also for bringing out the conference proceedings on time. Thank you all. Well, last but not least, the financial support from the industry has been tremendous, and it was much needed, and it was needed on time. So we would like to appreciate our sponsors, Class NK, Cochin Shipyard Limited, KMRL, Conceptia Technologies Bangalore, GRC Kolkata, Dostas, Essendo Maritime, Aries Marine and Engineering Services, and Sea Delta Marine and Offshore for the timely and valuable contribution for conducting this event. Please pardon me if I have missed out anybody. Once again, thank you very much. And I look forward to seeing you all in the technical sessions. Thank you very much.
That brings us to the end of this inaugural session of the first international conference on advances in naval and ocean engineering, iCANOE 2021. Before we start the next technical session at 11 o'clock, we'll take a short tea break. Tea and snacks are arranged outside. So please help yourself. Please partake in that. Thank you. Thank you very much. Thank you. Hello, sir. Hello.
Oh, yes, Rajesh, you're there.
Sir, we will have 5 more minutes extra, sir, for tea break. So shall we start at 11:05? Is it okay?
Yeah, fine. You just tell me. Okay, no problem.
Okay, sir. Okay, thank you.
All students, please come into the seminar hall in 1 minute.
Sir, shall we start, sir? Krishna, sir.
Okay, Rajesh.
Sir, can you turn on your video also, sir?
Yeah, I did. Okay, thank you.
Okay, sir.
So, want me to share my screen or?
Sir, let me officially welcome you. Sir.
No, that's okay. I thought just to check whether the screen sharing is working or not.
Yeah,
Okay.
mic seems to be okay.
Yeah, you like to wait for more people to come in or? Because I
Just
see
one
that
second.
it's very scanty. So it's up to you. Okay, if you want to start, because there are many people online also.
Yeah,
So,
I will just 1 second, sir.
yeah. Yeah, I can see Dr. Ebenezer there. Hi, Dr. Ebenezer. Okay.
Okay. A warm good morning to all of you. So today we have with us Professor P. Krishnamurthy sir from IIT Madras. Sir did his BTech from CUSAT in 1981 and ME from Stephens Institute of Technology, PhD in Marine Hydrodynamics from IIT Madras, and PDF from Glasgow University. Sir is having a teaching experience of more than 40 years, including faculty in ship technology, and from 2006 onwards, sir is a professor in IIT Madras. Krishnamurthy sir is Vice President and Fellow of RINA, Chairman of NRB, Naval Research Board for Hydrodynamics Panel. Sir is member of SNAME and member of ASME. Sir has published more than 130 research papers and guided many research scholars in PhD and MS. Has undertaken lots of sponsored and consultancy projects. Sir has chaired different national and international conference and recipient of Government of India Scholarship for Higher Studies. Sir is also a recipient of a Technological Innovation Award by SRI STI. Welcome, Krishnamurthy sir, for the invited talk on indigenous development of PMM experimental facility at IIT Madras for surface ship maneuvering predictions. Over to you, sir.
Okay, thank you, Dr. Rajesh. So I'll just go straight away. It is something like, for me, even though I'm remotely here in Chennai, something like homecoming. So I've been with the Department of Ship Technology for, I think, nearly more than 30 years, 5-6 years as a student, and then taught there for about 20-25 years. Of course, I was away about, I think, 8 years during that period to do my higher studies and postdoctoral fellowship and all that. So that's what, so I used to visit the department often whenever I come to Cochin. So nowadays, due to COVID situation, I'm not coming to Cochin and also not visiting the department. Okay, let me share the screen option. I think should work now. Are you able to see the screen?
Yes, sir.
Okay.
Yes.
I think I have to move one slide up. Yeah.
Yeah.
Okay, minimize my video. Okay, I think. Okay, so just coming to the topic, what I would like to present here is indigenous development of a planar motion mechanism, experimental facility at IIT Madras for surface ship maneuvering prediction. What it means is that maybe there are people who are not in the background, with the naval architecture background, or the people who learn naval architecture might have forgot about PMM. The PMM is it's an experimental, it's called planar motion mechanism. Basically, we use it for, sometimes people use HPMM, horizontal PMM, primarily used for surface ships, not for submarines. And yeah, in the PMM, what you do is it is an add-on facility, basically to a towing tank facility. So people must have seen towing tank where all these resistance propulsion experiments are carried out. And this is an add-on facility to that. And in the PMM facility, you can just fit a model and subject this model to different modes of prescribed oscillations and measure the forces, hydrodynamic reaction forces, and also the moments, and use that data to get the hydrodynamic coefficients, or we call hydrodynamic derivatives. And these derivatives are used in equations of motion representing the surface ship maneuvering. And along with that, you put rudder and propeller effects And then you solve this equation to get the velocities and subsequently integrate it to get the displacement or the trajectory of the vessel. So this is the procedure. Okay, this is a prediction of the ship maneuvering from the model test. So PMM is a facility which gives most of the hydrodynamic coefficients, and that is being used when only 2 places in India have that now. NSTL Vishakhapatnam, that's a Naval Science and Technology Lab. And this is the one, the second one, which we have developed indigenously. Yeah.
Sir, the slides are not moving.
Yeah, I'm just explaining. I'm just
Okay.
okay. Coming to the background. So okay. So that is the background of this topic. Okay. Right. So what I'm going to outline is the introduction to the maneuvering. You have to understand that. You are able to see the second slide now.
Yes, sir. Yes. Yes.
Yeah, okay. Okay. So I looked at just basic introduction to maneuvering, mathematical modeling of surface ship maneuvering, then PMO modes and formulation, CFD simulation of PMM. I think I've shifted to later, and the design of PMM fabrication, what we did, and challenges faced and solution to that, and finally some results and discussion about that. The ship maneuvering, you know, that is the ability of the ship to keep or change its state of motion. And motion stability is generally, referred by straight line stability, directional stability, and positional stability. I'm not going to the details. And so basically, I've explained that equation of motion. You're able to see my, I think, let me see. Okay. Yeah, so the cursor here, okay, equations of motion, you have to solve the maneuvering equations of motion and get the prediction. So to get the, as I explained, you can use numerical methods or experimental methods to determine the hydrodynamic derivatives, okay? So now, you know that the IMO has set criteria for maneuvering of ships. So these criteria need to be met for the ship to operate. And nowadays, IMO is insisting on to get these things verified even at the design stage. So using CFD methods. And also maybe just prior to the finalization of the design, better to go for an experimental method to ascertain the maneuverability of the vessel and to check whether the parameters are within the IMO specified criteria. Okay. So this is what is, I'm not going to the criteria details. So if you look to the equations of motion, this is the equation what you see here. This is given only for an X equation. So basically you give, you can see various terms. It's a familiar equation which maneuvering, the people who studies the maneuvering, and similar equations you get for the other modes like, sway or yaw mode and so combined mode and all that. So then you can estimate the derivatives. Basically, these are the XH you can see, which is coming on the right hand side. I think it's given, yeah, here XH and all that. This is coming. And then, okay, I think there is some mismatch here. The equations are merged together. These are the three equations, something got juggled up. Okay. So this equation, this is basically surge equation, and from here it starts the sway equation, and then here is the yaw equation. Okay, and these are the rudder and propeller derivatives which are used, and these are the hydrodynamic coefficients which appear in the equations of motion. Okay, and now when you come to the ship maneuvering, the approaches what you use is in model test. What you do is you in the prediction you go for the experimental method, the ship model. You can do straight away the free running model. That is, the ship model will be fitted with the model propeller and model radar, and the propeller will be RPM will be adjusted to get the required speed, and the radar will be operated to get the required trajectory. Okay, so that is what is done. So it's a free running model. That's the model itself is running with its own model propeller and radar. Another method approach is, so we go for determination using, Okay, that is a free running. Another method is using the modular method, where you use a mathematical equation. As I explained before, you estimate the hydrodynamic coefficients appearing in this mathematical equation, and then you solve that to get the vessel trajectory. So then you can, find the turning circle or zigzag maneuver and all that, and check with IMO requirement. So if you look to the PMM modes and formulation, okay, this is a conventional PMM method where you have two oscillators, one at the stern and one at the bow. And these two oscillators can be operated independently, and you can just control the phase difference between these two oscillators and get the required mode of motion in the in PMM. So basically that's what is explained here. And so each position you may find that there's a load cells which will measure the loads, and you can estimate the moment from that displacement of this the distance between these two struts. Okay, so that is an and yeah, so these are the different modes when you consider the PMM. This is a pure sway motion where the model axis always remain parallel to the axis of the tank. You can see that this is the line which shows the axis of the tank, and the model axis is parallel, always written. So this oscillates like this, and so this is a pure sway mode. And when it comes to pure yaw mode, you can see that the axis of the model is always tangential to the path. You can see that, which is always, so this is called a pure yaw mode in PMM oscillation. And you can also use combined sway and yaw, where you give a drift angle. You can see here this model, the drift angle is given and it follows some similar to the yaw motion. So you get combined sway and yaw. The drift angle gives a sway effect. So this is a combined yaw, sway and yaw. So these are the three modes of oscillation in PMM, from which you will be able to get all the required hydrodynamic derivatives which appear in the maneuvering equations of motion. Okay. So once you get that, once you perform the test with these modes, you get the force history, or you record the force history, and you can use the force history, which is sinusoidal in nature or maybe oscillating, and you can represent it using a Fourier series, and using this is what is represented here. And from the Fourier series coefficient, you will be able to estimate the hydrodynamic derivative. That's a process involved, procedure involved, through which you will get the hydrodynamic derivatives. Okay. So in this present study, what you have done, KCS container ship is a Crusoe container ship, which is an international benchmark being used by various leading researchers around the world. So we also selected this KCS model for the study so that we could compare it with international, the results presented by different agencies from across the world. So we just went for the same ship. It is the full-scale dimensions and model scale dimensions are here. The model is having a scale of 1:75.5. Okay. So this is a fabricated model. The model has been fabricated in our in-house facility. This is a model of the container ship, that KCS model. This is a model propeller which has been made using using a stainless steel material. You can see that stainless material, and also this is a rudder. So this is the we have used this. We use a rapid prototype machine for that. Okay. So so coming to the experimental PMM experimental setup, you can see that there's a view of the towing tank of IIT Madras, and there's a carriage what you see here, and you can see the PMM is already erected in this. There is a open space inside the carriage through which the PMM facility is attached, and the model is fitted to that, and that model is subject to oscillation. You can see the details of the arrangement here. This is the opening. You can see that this is the opening which we get in the carry. The opening what was available is only 3 meter by 1.35 meter. Okay, this is the opening space, and we have to utilize that space to accommodate the PMM plus the model and all the setup. So that was a big challenge. So we went through different difficult situations, because we could not alter the carriage, we could not alter the towing tank, because that is meant for other experiments. And so we have to find out a facility, find out this, utilize the space and accommodate the facility. So here you can see this is the PMM setup, what you have been. These are clamped. You can see there's 4 clamps which are clamped to the carriage, this bar. So this is actually suspended. It's rigidly suspended from this bar. And then this system, you can see here, this is a lead screw which gives a pure sway motion. There's a motor here. The motor is subject to a belt. It runs a belt, and the belt drives this lead screw, and then this it will move. You can see when it's moving, there's a rotation, there's a screw, and which will move along this, that gives a pure sway motion. And then you can see here is a motor which is mounted vertically, and there's a shaft connected to that and going directly to the model. And this can be subject to rotation, and both are servo motors. So, and then it gives a yaw motion. So that's how it's done. So you have to use this with the program which will give the required motion mode for the PMO. So the design was design, fabrication, installation. The process, what we did is initial estimates. Initially, we have to find out what is the capacity, what's the load, what is the load coming on the system, what is the load coming on the load cell. You have to make an estimation. So we had to do what is the amplitude limitation, what is the frequency limitation of oscillation. So all these things need to be ascertained. So these things were judged or estimated based on the space availability here. And so we found that up to 400 mm sway amplitude can be obtained, and a maximum yaw amplitude of 15 degrees. If the yaw amplitude, if you increase, it may go and touch the tank boundary. We need to give adequate clearance from the tank boundary as per the ITTC recommendation. So all these have been followed, and the maximum achievable sway amplitude has been found to be 400 mm. And your amplitude at 15 degrees. So the frequency also we have looked into. So based on which we are in a position, and we also know the model size, everything, we estimated what is the total expected force and moment, based on which you have to design the structure, design the load cell, and subsequent components. So all these things, preliminary estimates have been done before placing the or finalizing the specification, technical specification for the PMM facility. And once that technical specification has been made, then it has gone through various revisions and discussions, and finally, then it went for the tender notice. It was went for bidding, and finally, we could get the right bidder, fabricator for that, and so that's how it's installed. This is again going the frequency. You can see that maximum 2.5 radians per second, and the amplitude has been reduced marginally through 380, 15 degrees maintained for your amplitude, and model size maximum 4.5, but the model size which we use is only 3 meters. And another important thing you have to keep in mind is that the tank length is only 83 meters, and the oscillations, minimum 4 oscillations you should get for the PMM, and the oscillations will start only after reaching the steady speed. So we have only limited space. In that limited space, 4 oscillations, so all these restrictions come into picture. So now these operations, this I have seen, this is a more close-up view of that. This is the sway motor, and this is a belt. The sway motor is controlled, and then the belt drives this lead screw, and you can see there's a bearing unit, and which moves, and the model is connected to that. The model gets moved with that. This is what you show is a rotary motion. That's for the yaw motion. So in yaw mode, only this motor is operated. This is not required to be operated. But when it comes to, in same mode, this is operated. In your mode, you have to use both then, and also mixed mode, you have to use both. So that is arrangement. And coming to the load cell mounting, you can see that this is the load cell mounting here. There is a load cell kept here. So the reaction force coming on the model need to be, restrained with the load cell inside. And so that the mechanical system has been developed like that. And only the X force has been, Y force or tensor force has been measured using the load cell. The load cell used type single component load cell, which has been used in this setup. So we have two of these kept at the forward and the bow and stern positions of this, the equivalent positions. So, and this load cell readings go through a signal conditioner because there will be a lot of noises generated. The signal conditioner is an electronic system to some extent, and that data is being fed to the system, or it is recorded. That's a measurement, system. So the operation of the PMM is done by a drive control panel, which is again placed inside the carriage. We could find some space. This whole unit is a control panel. There's a cabin for the control units. This shows the inside view of the control panel. So this has been done, developed. This has been, and then the whole operations are controlled from using the PLC, which is being used and controlled. So this will, control the movement of the two servo motors, and that is the yaw motor and also the sway motor. And by changing the parameters, which can be put into the HMI monitor, so from which you will get the, you will input the information and using a user-friendly menu, and that is transferred to the drive system, and drive system operates the PMM system. Okay, now this is another view of that. This is a view of the model. This is a different model, I think, which is kept here. And here, this is a system. If you look, this is a carriage. You can say this is a HMI here, and then you have this is the carriage system. Carriage is driven by 4 motors, and so that is arrangement inside the carriage. Then from this, you have the PMM frame. There's a connection for sway mechanism. There's another one for yaw mechanism, and finally it's connected to the ship model. And by using the PLC and the drive system, these mechanisms are driven in a controlled way to get the desired mode of motion with the desired amplitude of motion, desired frequency. So that's how this is controlled. So this is already, we have discussed that. There's a motors here. You can see this is a computer model and this is the actual one. The diagrams show where is that motors kept. So this is the, this is a yaw motor. You can see from here, this is the yaw motor, sway motor, this is the yaw motor, and then the lead screw. And so all these mechanisms, these are the mounting, this violet color are the mountings, and the green one is the bar, which is part of the carriage. So mounting arrangement also explained, this is a mounting mechanical system. This will get mounted onto the base of the model. And so with the load cell giving the reading at the 2 positions. Prior to any experiment, the load cell need to be calibrated. So we made setups for the calibration of the load cell. We did a load cell alone and also the load cell attached to the model. We found that this is a better way, that load cell attached to the model gives a better calibration constant, accurate calibration constant. And this shows the plots for that, and from which you get the constant for force and moment. So this shows the oscillation. So we face some problem. There was some jerk, oscillation initially. This translation or deviations are taken by the bevel gear system, which have the gear teeth giving a vibration and also a jerk. So these problems have been identified and rectified. You can see that the force history, how it's varying with the jerk. You can see that the spikes coming all due to the jerk. And you can see that the blue one, which is a result which we got from NSTL with the same model. So the model was taken to NSTL later stage, and we did PMM and free running tests there. So this shows the history of the forces and all that. So I'm not going to the details. So what we did is we attached the model, we did the drift test. You know that what is a drift test? That is the with a fixed angle. Here you can see this inclined the model with which is an angle of I think 15 degrees. So which is run in a static condition without any oscillation. You can use PMM for that, and also you can use PMM for the oscillation test. So these are the what you do is you for different angles you plot the forces, and then you from which you can get the derivatives for that. When you coming to the dynamic test, that is a pure sway oscillation, pure yaw oscillation, and mixed mode. These are the parameters used for that, for the oscillation. And you can see that in the videos here, how this is a pure sway, how it's done in the model test, the PMM, how it's operating. You can see the different views, one from the forward side, one other from the rear view, and one from the top. So this is how the sketch shows the pure sway motion. You can see how the motions are obtained in the PMM setup in here in IIT Madras. And these are the force histories. So how we got it and how we filtered and find the graph. And this history has been used subsequently for Fourier series representation and analysis, then to get the hydrodynamic coefficients. There's a mathematical procedure. Then comes the pure yaw motion. You can see that the model is rotating here compared to the previous one. You can see that model rotating. So this is a pure yaw motion, which you see the different views, which has been. Dr. Rajesh, you're able to see the video? Rajesh, you're there.
Yes, sir. Yes.
Seeing the video, right?
Yes, sir.
Okay, fine. So that is how this pure yaw motion, and this is force history and moment history from that. And then comes the mixed mode. These are three modes, used in PMM. That is pure sway, pure yaw, and mixed mode. This is a combination of sway and yaw. So this is, you can see that there is a drift angle, and also it is doing something similar to yaw motion. And these are the force histories measured from that, and from which we have estimated the hydrodynamic derivatives. You can see these are the hydrodynamic derivatives which appear in the equations of motion, and the corresponding values are shown here. Once you get the hydrodynamic derivatives, as I explained before, you get into the mathematical model, defining the surface strip maneuvering. And then you substitute these hydrodynamic derivatives in the equations of motion, and also include the rudder and propeller derivatives. And then you can solve this equation, that is the sway and yaw equations jointly. And then you get, after substitution, you get the sway and yaw velocities. And then you integrate it, then you get the x and y coordinate of the vessel. And okay, so against time. So that is what you get. So if the trajectory is a turning circle, I think this turning circle has been, the rudder is put to 35 degrees, and then a turning circle maneuver is performed. That's how it's predicted. Similarly, you have a zigzag. These are the two things which you have seen in the IMO slide, which prescribes the zigzag maneuvering parameters and turning circle maneuvering parameters. So you can simulate that here. The same model has been taken to NSTL Visakhapatnam, and where we could use their new facility, that's a maneuvering seakeeping basin. And we did a free running test and also the PMM test there, because we wanted to check the values obtained from already established facility and how it's comparing with the facility which we developed. So this actually is a study primarily for validation of the PMM facility developed at IIT Madras. So this is also a hectic task. We had to take the model to Vishakhapatnam. That team had to go there, and they had to, of course, NSTL, the scientists, they helped a lot, and so they helped in setting up the whole thing, and they were, lenient in providing the facility to us, and so we are thankful to them for the accommodating us there. And subsequently, this is a turning circle maneuver, which has been done, the video which you have seen. If you look at the trajectory, this is how it's obtained. So these trajectories values are compared later. This is a zigzag trajectory for the free running model test. When you say it's a free running model test, that means the model is run with the help of its own propeller and radar. Okay, so that is how, and it is controlled. So subsequent to that, what we did is say what all the most of the PMM facilities are work in deep water condition. So, but this is fine when you talk about vessel going in ocean going vessels and the vessels operate in deep sea condition. The parameters, the hydrodynamic derivatives you get from this type of test in deep water conditions are okay. But when it comes to the ship comes to in a restricted waterways, particularly when it operates in inland waterways or rivers or maybe in the harbor area, the shallow water effect come into picture. That is bottom, feeling of bottom come into picture. And that is feeling, hydrodynamic feeling. It's not that the ship is touching the bottom. So when it's getting closer, that's a clearance, under keel clearance is less, the effect will be more. So we wanted to study that effect using the PMM. And so we wanted to have a platform. So, and the platform should have an adjustable water depth. And platform should not be a permanent fixture. It should be detachable, removable, and it should be handled properly, and it should give sufficient length. All these problems were there. So we just did the calculations. We went ahead with the design. We found that 1.5 meter along the one piece, 1.5 meter, the width is 3 meters. So that is how it's done. And we had an arrangement for lowering and changing the water depth or changing the level of the platform. So we did the studies, and the PMM with the ship model operates over it. So we get the shallow water effect with the this facility development. So that means we had developed a PMM facility which works, which is usually done for deep water condition, and we developed platform with the adjustable depth, which could give the shallow water effects on the maneuvering characteristics of the ship. So this is different modes and done over the shallow water. You can see the red color below this H/T, that is water depth to draft of the ship of the model is 1.2. Is a really shallow water condition. You can see the operations. And so subsequently, we predicted, I'm missing many steps in between now. So finally, we predicted what would be the effect of this shallow water on the trajectory. You can see that if it's a deep water, it's coming very, it's only this much, whereas the shallow water, it may go up to very large. So that means a vessel operating in shallow water region takes much larger space for a full turn compared to the same vessel operating in the deep water condition. So the vessels, when it enters the shallow water region, need to be very careful because the controllability becomes very difficult and sluggish. We also did some CFD analysis. I'm not going to the details of that. Maybe time is a constraint. So this is the modeling part and parameters. So we did with the simulated the same pure SAY mode, pure yaw mode, and these 3 modes. You can see how this CFD analysis, this pure SAY mode, and you can see on this side the force histories here. And then what you have this is for the pure yaw mode. Okay, this is in the CFD environment. Of course, this is not matching with the title, but still I thought maybe just show you this CFD analysis and how it's compared with the experiment. And so from the CFD, we estimated the turning circle and zigzag maneuver. And so also in the CFD environment, we did a free running test. The same model size, same model parameters. This is a free running. You can see that they are running. The whole domain is, this is a relatively new option available in the Star CCM CFD package. So the domain itself, this saves a lot of computational effort. Otherwise, you have to do, identify the whole domain and do the analysis, which is a hectic thing. And now here, this option where the domain will move with the, oriented with the vessel. So that is how it's done. So that is done for different, this is a turning and zigzag menus, both we have done. And finally, we made a comparison between the NSTL PMM, what we do, the NSTL PF free running PMM experiment at IIT Madras and PMM CFD. So you can see that the correlation, they are very encouraging. And yeah, so this is what is done. I just want to share with you what we have done at IIT Madras. So first thing is indigenously developed. You have to know that, see, the PMM manufacturing or, or supply, commissioning, everything is done. It's a monopoly of a company in UK, Cousins. I think recently it has been taken over by Company Trumpers. And so we approached them to give a quote for the PMM facility in our in towing tank. So they, the few years back, maybe 7-8 years back, or even before, they quoted 4 crores. Okay, it's a small facility. So we did not have funding. IIT will not support this. So then there will be a thought of go for indigenous thing. There are other advantages. See, this maintenance and repair become easy. It's locally available. Cost is less. And so we will gain a lot of expertise in the PMM mechanism, and also modifications if required. We are in a position to do it now because we developed it. So which involves basically a lot of mechanical systems, electrical systems, electronic systems, and control systems. So there are many things which need to get integrated into such a facility. So we took the challenge, we did indigenously, we established it, we verified it, we calibrated it, we shown that it's working fine, no problem. So, and the cost, what we could make, we had to give is only 40 lakhs. That is 1/10 of the cost we could get a facility. So this is a challenge. We faced many problems. We had to change, some of the mechanical systems, some of the control system, electronic systems, load mounting systems. We had to go through it. Even load cell we changed. So all these things were there as part of the development. In spite of all these changes and difficulties, we could manage with the, with the 40 lakhs. And our thanks are due to Naval Research Board who supported it through a project. And also thanks to the Rockwell Automation. It's an American company having an office in Chennai. So Mr. Babu Shekhar, I still remember him. He was supported, extensive support for this system. So of course they did not make any profit. Maybe they might have run into loss, so they helped us. So that's an advantage. There's a challenge in the indigenous development of any system, particularly the PML system, which is more complicated. And so we did tests with the PMO for a range, and we also simulated the trajectories, and we have compared it with the free running test. We have compared it with the CFD analysis. We have compared with the NSTL results and all that. So they are very in an acceptable range. So this is what's all about. I like to share with you for today. So maybe if you have any questions, I'm willing to take. We still have some more time. Dr. Rajesh, is to you. Can I stop the presentation?
Yes, sir. Yeah. Thank you, sir. Thank you very much for the invited talk. Now, this is a question and answer session. So I request the audience to ask a few questions if you have anything. If you have any questions, you can ask now.
Professor Krishnakudi, thank you very much for a good talk. There was some scatter in your experimental results.
Yeah.
What is the primary reason for that?
Say, basically, the system is mounted on a carriage, Maybe I think you are referring to this one, right?
Yes.
Yeah.
Yes.
So and basically, these scatterings are, basically the noises which is coming from the carriage movement. Carriage is operated by 4 motors. And also going to the rail. Rail you cannot expect is perfectly smooth. So the rail movements gives some noise, vibration, and also the PMM system when it oscillates. Also, there are many mechanical systems which are used, so it may induce some variations. So this we have to eliminate. Even though the signal conditioner is there, still some of the data is not eliminated. So what we do is we make this is given a fit to that, to the points, mean fit, and based on that curve is used for further analysis for the Fourier series representation and further analysis of that.
I have one more question.
Yeah,
In your
please.
CFD analysis, we can see that the wake is touching the boundary. Is this a cause of concern?
CFD here?
Yes, in your moving domain analysis.
Moving domain analysis, okay. Here.
Yes.
Okay.
The wake is touching the boundary of the domain.
No, the thing is the vessel which has already crossed the wake area, and vessel is not moving at a very high speed where you expect the wake to overtake the ship, and also the whole test is done within 1 circle. If you are doing it, then it won't get into the wake of the next cycle. Okay, so that wake effect, I think you see all these domain dimensions are based on the guidelines of ITTC. So that's how it's taken. So I think we have followed that criteria, and we have gone through the publications and also ITTC guidelines for CFD simulations. So that has been taken care while the analysis is done. So I think it's not going to influence the results.
Okay, thank you very much.
Any more questions?
Good morning, Professor Krishnanguti. This is Manoj from Ship Technology Department.
Yeah.
Morning,
Manoj, yeah.
Sorry, sir.
Morning. I'm just pushing back. Yeah, that's it.
Just a follow-up question on this very aspect that Dr. Ebenezer has asked.
Okay.
In reality, when you do this experiment in a wave basin or a maneuvering basin, you're basically entering into its own wake, right? It's that memory effect.
Entering when you are doing okay, if you're using that, if you're going over and over, then you have this problem.
Can you come back once again, sir?
No, if you're doing a test, if you're taking a circle 2 times, then the second time it will be in the wake of the first wake, the first turn.
Yeah. So there, the resistance or whatever parameter that you measure might be slightly different from the first turn or first complete turn that you have measured, right? If you are doing the experiments, will CFD take that into account?
Yes, well, of course, CFD takes care of that into account. So now the question is the wake, whether it's affecting. Here the thing is actually what we are trying to, in the free running case, if this is a free running. So what do? You're talking about free running cases, right?
Yeah.
Okay. So in this free running case, what you have is you are looking only to the trajectory position. You are not measuring any forces or moments here.
Okay.
So you measure only the trajectory. Okay. So that information is used.
Okay. So that's only in the rotating arm that becomes an issue. Okay.
No, when you consider in the prescribed motion, that is like PMM or rotating arm technique or maybe drift test and all that, there you have to be careful about the water condition there. So there should not be, so that will affect the reading. Whereas here, of course, as you said, it may affect the subsequent turning, but the influence has been found to be insignificant. So if you are doing a free running turning, the subsequent cycles almost follow the previous cycle. So it's not it's a problem as of now. I mean, as noticed.
Okay. In your presentation, you said the maximum sway amplitude is around 40 millimeter, right? Sorry, 400.
400 mm, right.
Did you see any effect, wall effect from that interfere with your?
That's also a good question. Actually, we have checked with ITTC requirement. What should be the maximum amplitude in relation to the tank width, and also maybe some other parameters. So we have checked it, and also we checked with the space availability in the carriage of IIT Madras. So considering all these aspects, finally we restricted the maximum sway amplitude achievable is 380 mm. So all the subsequent calculations regarding the force, velocity, force acceleration, velocity, displacement, velocity and acceleration, subsequently the forces were based on this. Then also we looked into the frequency of oscillation, how much maximum frequency it can go. That frequency again depends on the speed of the carriage and also the length availability of the tank. Because as I mentioned, you need to get a steady oscillation to get the correct forces. To get the steady oscillation, you need to perform at least 3 or 4 oscillations. So for 3 or 4 oscillations with the assigned speed of the carriage, what is the length of the tank required? So with that, we consider all these aspects, and then only we estimated, okay, this is the frequency maximum which it can go, or minimum frequency it can go. All these things, what is the speed it can go? So all these constraints are there when depending on the restrictions of the towing tank facility.
Okay. The other question I have is with regards to the shallow water test. How did you manage to fix that false bottom? Like, is it clamped onto the?
It's a big challenge. You see, when you're using the towing tank existing facility, see, you cannot tamper with the facility, right?
Yeah.
Okay, so what you have to do is you have to make a setup in such a way that without tampering with the existing facility, how can you erect the platform? That's a good question. So what you have is, say on the rails, you can see that on the rails are mounted onto the wall. And the wall in the mounting arrangement, we have the bolt, nut and bolt, okay?
Yeah.
So we find that there is a nut which is coming. There's a nut of I think 1 inch or maybe 1.5 inch, which is protruding out everywhere.
Okay.
So what we did is we used that space. We put a clamp on this nut, and through the clamp we supported the platform. Okay.
So you keep changing the depth. You can adjust the depth every time you want.
Then we have you can see here there's a lead long screw. You adjust the screw of every support so that you can change the position of the platform. So if you have a bolt here, you have the thing here. So you just rotate at the top. Then what you do is, it's not a very sophisticated arrangement, but this is the one we could come up with. And so when you rotate it, then the platform level will change.
Okay.
So this arrangement, which we designed without tampering with the facility, because this tank, the rail facilities are very need to be very precise, and we should not tamper with it because it has to be used for many other experiments.
Yes, I understand, sir.
And also, if anything goes wrong, it will fail.
Yeah, that's true. The other thing is, how did you manage to get rid of that vibration, that jerk? I think I didn't follow.
No, what I'm saying is, initially when it was designed, see, you have to transfer the motion. The motion it was initially given with the, I think that's a gear. There's a gear transmission was used for transferring motor to the motion, right? So the gear transmission, the gears have the backlash. You know that there's a backlash for the gear because depending on the number of teeth and the backlash changes. With these backlashes, we are introducing a vibration. So what we did is we changed that to a belt drive. The belt drive gives a smooth transition. So that vibration is avoided. So we had to redo the thing. And another thing is about the jerk. So what we do is, if you look to the PMM oscillation, usually starts with the maximum amplitude. And maximum amplitude, it starts all of a sudden. Then it was finding that there's a sudden, movement. So what we did is we started from the 0 position and gradually increase that. So we can say that because it's a cyclic thing, sinusoidal thing, we can start any position of the cycle. So we just changed the position of the cycle, and then that jerk problem was also resolved.
Okay, okay. Thank you, sir. Now that you have got this experience in building it indigenously, would you be designing it for others? If we, I mean, this
No,
distant
first
dream.
thing is IIT is not into commercial, level. So we have taken the challenge. Actually, it's not coming under our purview to design or to develop a research facility or experimental facility of this sort. But as I said before, the cost quoted was 4 crores. We did not have money, and IIT will not fund for that. So we have to find a source, some other source from outside. Luckily, we approached NRB. NRB happily supported it. So through a project, and so we could convince them, because we did the background work before going to NRB. He said, okay, this is the cost of the system. So we did all the background studies and everything. We consulted the prospective vendors. We asked them, we interacted with them in many meetings. And we also included in the team, the internal team, senior professors from electrical department and mechanical department who also supported, because we are not, good in all these things. So it's a team which helped in, reaching this or developing this facility. So finally, we worked out with, as I said, Rockwell Automation is an American company with an office in Chennai. They also have done some projects for the electrical engineering department. That's why we got in touch with them. And so we discussed with them, and I asked them what would be the cost. They said 25 lakhs maybe. I said it will take time, NRB sanctioning, getting fund and getting the system in place. It may take maybe 2-3 years. So I said, we'll put 10 lakhs over it. So we, in the NRB proposal, we said 40 lakhs. Plus project stuff, everything, I think the whole project was nearly 1 crore from NRB, 95 lakhs or something like that. So we got the project, and we could implement, and we got very good appreciation from NRB, because they're happy that with the NRB fund, the project has been successfully implemented.
Perfect, sir. Thank you. Thank you very much.
Yeah. Thank you.
Any more questions? Student side? No. Thank you, sir, for the very informative session, and as a part of gratitude towards your valuable information and your speech, we are presenting a memento as well as certificate.
Okay, it's okay, but I don't know how you're going to hand it over to me in
Yeah.
this mode. Okay, maybe you can take a photograph of it and send it to me.
Sir, it is there, sir. I mean, it's we are sharing it in the screen. Can you see?
Okay, fine. Okay. Thanks a lot. I wish I had been there, but unfortunately I couldn't. I was there in Cochin, I think last month, maybe beginning of this month. So anyway, because of the COVID situation, we have to look into all these modes of remote, online, hybrid modes and all that. So people are getting used to that, and that has been now changed to a normal mode. Okay, thank you, Dr. Rajesh, and others there. Thank you for the opportunity. Bye.
Okay, thank you, sir. Thank you very much. Now, morning session is over. Yeah, so afternoon session will start at 2 o'clock with the technical session on hydrodynamics, and then technical session on computational fluid dynamics. All of you can come here for the afternoon session at 2 p.m. So lunch is arranged in the floor. You can have the lunch also. Anything else? you wish to say? Otherwise, we'll wind up for morning session classes. Okay, thank you. Thank you all.